class, and thank you for joining me for your next notes video. Today we're going to be focusing on more multiplication properties when it comes to exponents. So what I mean by that is, today we are going to be focusing on stuff that looks like this. A power raised to another power. We want to investigate, what does this mean? What happens? So on the blank page of your packet that says activity, this is where I'd like you to be sketching down this stuff that I'm writing right now. The way I'd like you to consider this, when you have a power raised to a power, is I want you to write it out. X cubed to the second power, all that means is you have x cubed twice. Well, what does that mean? Well, this is what we investigated previously. When you are multiplying these things with like bases, you know you can add the powers together. So 3 plus 3 gives us a power of 6. All right, well, what about something like this? All right, x to the 4 to the 4th power. What happens here? Well, this means we have x to the 4 times. So when we actually write that out, x to the 4 times, 4 plus 4 plus 4 plus 4 gives us x to the 16. So I'd like you to consider what's happening here. We have a 3 and a 2, we're getting 6. We have a 4 and a 4, and we're getting 16. So we'll come back to this, but I want you to start thinking about what pattern is happening here, all right? So another thing I'd like us to consider is, what about something like this? What if you have more than one thing in that parenthesis? Well, that really doesn't change much, does it? All that means is we have 3x squared. We have that twice. Well, 3 times 3 gives us 9. X squared and x squared. Now we're just multiplying those like bases again. So 2 plus 2 gives us an x to the 4. So, what am I hoping we're gaining by this? Well, I'm hoping that we're seeing a pattern here. When we are raising a power to a power, I hope that you realize what we're getting is a to the m times n. We were multiplying those exponents this time, raising a power to a power. And raising a product to a power. Well, what that's doing is applying that power to both pieces of that parenthesis, okay? So this is mainly when we're talking about parentheses, okay? Power to a power, oftentimes you see parentheses here. Now, if you forget the rule, so you don't get confused, always feel comfortable expanding it out, okay? You can never go wrong expanding these problems out, because I want to make sure that you're doing them correctly. So if you start confusing these rules from what we were doing in our previous notes, always feel free to expand it out. Now, to get a little bit more practice in, first, write the simplified form of these. Remember, don't leave any negative exponents. We don't want any negative exponents here, all right? So, what are we working on? Well, x cubed to the 4th power. So, if I were to write this out, that's saying I have x cubed 4 times. So you can see 3 plus 3 plus 3 plus 3 gives us 12. Or using our new rule, since you can see we're taking a power of a power. 3 times 4 will give us x to the 12. what about our next one? P squared q to the 5th power. So again, you could easily write that out. P squared q, P squared q, P squared q, P squared q, P squared q. You could write that out and add up the powers that you see. Or you can use our new multiplication rule. So P squared to the 5th power, 2 times 5, we're going to have 10 of those. Or again, you could have gotten that by counting up. P to the 2, P to the 2, P to the 2, P to the 2, and P to the 2. You could have counted up if you expanded it out, okay? Now for the q's, remember when there's nothing written, it's basically saying it's to the 1st power. So power to power, 1 times 5 will be q to the 5th. Or again, in your expanded form, if you're to count it up, you'll have q to the 1 5 times, 1 plus 1 plus 1 plus 1 plus 1. That's another way to get it. So again, always feel free to write it out if that makes more sense to you, okay? If you feel like you may accidentally confuse some of these rules. If not, you can start using this multiplication rule. So for example, for number 3, m to the negative 2 times n, all to the 4th power. Power of a power, so I'm going to multiply my exponents. So I have my m, negative 2 times 4 gives me a negative 8. My n, don't forget when there's nothing there, means a 1. 1 times 4 gives me 4. But don't forget, we can't leave any negative exponents. So I'm not going to leave it like this. That m to the negative 8, remember, when you have a negative exponent, all you have to do, send it to the opposite location in the fraction. And so that would be the final answer that I am looking for. Now, to start dabbling with things a little bit more complicated. So, here we have y to the 3 times y to the negative 2, y to the negative 1st power. All right, this is getting a little messy. Now, when you see things like this, notice inside that parenthesis, you have y's being multiplied, okay? So that's where I'm going to focus first. I want to focus on the fact that inside the parentheses, I have y's being multiplied. So I'm going to deal with that. Now, remember, when we're just multiplying things with like bases, that is when we use our adding exponents rule, okay? So we have y to the negative 2 times y to the 1st. Well, what's going to happen in there? Negative 2 plus 1, we're going to get a negative 1 exponent inside that parenthesis. Again, PEMDAS says deal with parentheses first. So that's what I've done. I've simplified inside the parenthesis first. So now that I've done that, now I want you to notice I have a power to a power. I need to deal with that now. So power to a power means I can multiply my exponents. Negative 1 times negative 1. That's going to leave me with a positive 1. Okay? So, now I've dealt with my power of a power. Well, interestingly enough, look at what I'm left with. I have y to the 3 times y to the 1. I'm back to a simple multiplying problem. I'm multiplying two things with the same base. But now that I'm back to multiplying two things with the same base, I'm back to adding my exponents. So 3 plus 1 leaves us a y to the 4th power. All right, so those are the steps that we're going to be taking. All right, clean up inside a parenthesis, do powers of a power, and then finish up with any multiplication that's left. All right, so looking at number 5, looking inside both of those parentheses, I really can't simplify anything inside the parentheses. There's no combining of variables in there. So I'm going to go straight to my power of a power rule, all right? So here, power of a power. So n to the 5, 2 to the 2. 5 times 2 leaves me 10. How about my other one? Well, here, remember, if it's not written, it's m to the first. And now I have multiple things in that parenthesis. So that means that third power applies to every one of those things that's inside my parenthesis. So I take 4 to the third power. That gives me 64. M to the first to the third power. 1 times 3 gives me 3. N to the negative 2 to the third power. Negative 2 times 3 leaves me a negative 6. So, now in both my parentheses, I've applied the power to everything inside there. So what do I need to do now? Well, now I'm back to what we've done in previous notes before. Now I just have a chain of multiplication. So I need to look to see what can combine. Well, my 64 doesn't have anything to combine with, so I leave my 64. M to the 3. Now, the things I can combine are my n's. And again, we're back to multiplying like bases, so it means I'm going to be adding my exponents. 10 plus negative 6 leaves me with 4. And that's going to be the final answer that I am looking for. All right, number 6, and the last one on this page. So again, I'm looking inside my parentheses. I'm not seeing any variables I can combine. I'm not seeing anything to simplify inside my parentheses. So I'm just going to start applying my powers, applying my exponents, okay? So here I have an exponent of negative 6. So I'm going to apply that to both things inside. 2 to the negative 6, m to the negative 6. Now, notice my second parenthesis is to the 0 power. So because it's to the 0 power, remember what that means. That means that I actually can turn that whole parenthesis into a 1. So the whole second parenthesis simply turns into a 1. And we know multiplying by 1 doesn't even matter. So we can actually just get rid of that. So all we're left with is that first parenthesis. So I have that down. Well, I want you to notice we have some exponents here, some negative exponents. So we need to be very careful. So we need to take these and send them to the denominator. 2 to the 6 goes to the denominator and m to the 6 because, again, we don't want negative exponents. And since both things went to the denominator, all we have left in the numerator is 1 because everything had to go down to the denominator. Don't forget, that's how we handle our negative exponents. And 2 to the 6. We can actually simplify that, okay? If you type 2 to the 6 into your calculator, it should give you 64. So even a little bit cleaner way to write this would be just like that. 1 over 64m to the 6th power. All right, I think I'm going to stop us there, okay? We'll finish up our notes together at the beginning of class. So once again, thank you so much for joining me, and we will finish the rest of these notes together.